Hello, I am making this video for a quiz review for quiz 1, 417 from home right now. So not happy to be gone today and miss the review, but luckily I can make this video and hopefully this will help you. So this is the worksheet that I posted. It's the extra quiz review. I think it's the most similar to the quiz, so that's why I'm choosing to go over this one. Number 1 says, how many ways can a 6-person committee be picked from 20 people? So it doesn't matter what order I pick the people in, okay, because they're all going to end up on the committee. Whoops. So I can just go ahead and do 20, choose 6. We are choosing 6 people from 20. And I just literally throw that into my calculator. And I get my answer of 38,760. 38,760. All right. So looking at number 2, how many different ways can I make a word combination for the word committee? All right, so this is one of those linear permutations. So first we want to count how many letters are in the word committee. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 factorial, but there's a lot of repeated letters. So M repeats twice, E repeats twice, and T repeats twice. So when you throw that into your calculator, you get 45,360. Okay. Number 3 says a bag contains 6 red, 5 blue, 7 pink, and 8 purple marbles. How many ways can 3 red, 2 blue, 4 pink, and 1 marble be chosen? So here I'm actually making selections, which again is a combination. It doesn't matter what order I get these in, but I am making selections. And it's not asking probability, it's just saying how many different ways. So I don't need to make a fraction. I want 3 red, so I'm choosing from 6. So 6, choose 3. I want 2 blue, that's from 5. And I'm multiplying because it's an and problem. I want 3 red and 2 blue and 4 pink. So 4 pink from 7. And finally, let's see, I wanted only 1 purple. So I'm just going to put all of this into my calculator to get the final answer, but I am going to multiply all of this together. And it comes out to exactly 56,000 different ways for this to happen. Awesome. All right, number 4 says, how many ways can 7 people get in line to receive the H1N1 vaccine? What an ironic question, considering I'm here at home with the influenza. I think my strain is like the H2N3, but the doctor officially says I have influenza A. And guys, I didn't get a flu shot, so maybe I should have been one of the people in that line. All right. How many different ways can 7 people get in the line? This is just people lining up. This is one of those linear permutations. So you could do slat method here, but you don't have to. But it's 7 people to get in the first spot, leaving 6 to get in the second, 5, 4, 3, 2, 1. Oops, I did too many. In other words, 7 factorial. Which is 5040. All right, last one for this slide. We have how many different word combinations are possible for triangle? I don't see any repeats. None of the letters repeat at all. So let's see, there's 1, 2, 3, 4, 5, 6, 7, 8 letters, so it's just 8 factorial, which is 40,320. Alrighty. So there's the first 5 problems. Let's go on to number 6. Okay, deck of cards, here we go. All right, this is how many 9 card hands are possible that have. First one's 5 diamonds and 4 clubs. So you need to realize that for these card problems, you are making a selection. We are selecting 9 cards, but we're not looking for the probability that it happens. So you don't need to make a fraction. You're just looking for the total number of combinations. So for 5 diamonds and 4 clubs, you need to ask yourself how many diamonds are in the deck. Well, in the deck, there are 13 diamonds. So from those 13 diamonds, I need to choose 5. The word says and, so I need to multiply that. Now, it's a completely different suit. So there's 13 clubs. So from those 13, I'm choosing 4. And I'm going to take those in my calculator, and I'm going to multiply them. So it's 920,205. Okay, 1 king, 3 aces, 2 queens, and 3 jacks. Wow, okay. You need to ask yourself how many kings are in the deck. There's only 4 kings in the deck. So from the 4, I'm choosing 1. Now 3 aces. So there's 4 aces in the deck, and I'm choosing 3. 2 queens. There's 4 queens in the deck. I'm choosing 2. 3 jacks. There are 4 jacks. I'm choosing 3. All right. Throw that into your calculator. See what you get. Okay, I got 384. Now, something I want you guys to notice is that I am choosing 9 cards. So you want to make sure that the numbers that you're choosing all add up to 9. For example, 1 plus 3 is 4, 5, 6, 7, 8, 9. All right, now the next one says all face cards. All right, well, how many face cards are in the deck? Jacks, queens, kings. There's 3 actual face cards, but there's 4 of each, so there's 12 face cards to choose from. All right, but remember, I'm selecting 9 cards total. So from the 12, I'm choosing 9 of them. Just throw that into your calculator. And it's 220. All right, next one, let's see. This one's harder. 4 of one value, 3 of a different value, and 2 of a different value. Okay, I think this one's pretty tough, but it's not as bad as you would think. So let's just start with the first value. Now, since they don't specify which value, okay, we have to do something special. But for each value, there's 4 cards. So I am choosing 4 from 4 cards. However, we don't know specifically which value, so there's 13 possibilities. It could be an ace, it could be a 2, it could be a 3, and if I keep listing these, there's 13 possibilities. So it's going to be 13 times 4 choose 4. That 13 is accounting for the 13 different possible values that there are. Now, for the next one, it's 3 of a different value. Now, you have to really think about this, guys. This time, from 4, I am choosing 3. And instead of there being 13 possible values, it has to be different from the one before. So whichever value happened before, we're going to exclude that, meaning there's only 12 values left. Okay? And now we're going to use the same logic for the last one. Okay, for the last one, I'm choosing 2 from 4. But they don't specify which value, but I already used 2 of the values, so there's only 11 left. You're just going to multiply all of this up. It ends up being 41,184. Okay, Frem's co-ed flag football team of 18 boys and 13 girls. 7 boys and 4 girls are to be selected to go out on the field to play a nice game of flag football. How many ways could this be done? Okay, so guys, don't overthink. Just we're selecting 7 boys from 18. Oops, let's do this. 18. Choose 7, and the order doesn't matter. We are choosing 3 or 4 girls from 13. Again, order doesn't matter. They're all going to be on the same team. So that's it. Just multiply these together. So it ends up being 22,754,160. A lot of different ways to make that happen. All right. Last one for this slide. At Arlington Racetrack, how many different ways can 15 horses take first, second, and third place? This time, order matters, and I personally would do the slot method. So there's 15 options. Then 14, then 13. Another way to do this would be 15, pick 3. Order matters because it's first, second, third. So answer is 2,730. All right, let's keep going. Okay, guys, so we are rolling our 2 die here. So I would like to use the chart for this. Okay, I just drew one on there. Excuse me, it's really crooked, but whatever. There's the chart that you use. So this one we're not selecting, guys. We are just rolling 2 dice, so you don't need to do a selection. It says, what is the probability that you get a sum of 10? And also notice that we are looking for probability. So it's not how many ways can I get a 10, it's what is the probability that I actually do. Okay, so if we zoom in and look at our chart, how many 10s do we see? I see 1, 2, 3 10s. So it's 3, and there is a total of 36 possibilities. So my probability would be 3 out of 36. The next one is the probability of a sum of 7 or greater. Okay, so sum of 7 or greater. Let's just count it up. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 out of 36. This reduces to 7 out of 12, which is my final answer. Now, I realize this is different from the key, but I counted like 5 times in a row just right now when I checked, and I keep getting 21. So, can anyone confirm that? If maybe it's the flu, or maybe the other teacher got it wrong, but that's what I'm getting. I've counted like 5 times. I'm seeing 21. That is a 7 or bigger than a 7. So, email me if you guys disagree, if I'm going crazy. That's definitely a possibility. So, wait, was that? I guess we could have reduced 3 out of 36 to 1 out of 12. And this one reduced to 7 out of 12. Okay, let's keep going. Probability that the sum is not 4. Okay, well, looking at the chart, 1, 2, 3 possibilities would be a sum of 4. So for it not to be a sum of 4, there are 33 out of 36 possibilities. Okay, so that reduces to 11 out of 12. The answer key did something weird with fractions that I did not teach. I think this is the easiest way to get the right answer. So just go off of what I'm saying here. Okay, last one. The odds that we get a sum less than 5. A sum less than 5. Okay, so that's a 4, a 3, or a 2. So 1, 2, 3, 4, 5, 6. So there are 6 possibilities that I get a sum less than 5. Again, I'm going to find the probability first. So 6 out of 36. I'm not going to reduce until the end. That's the probability, which means the odds, 6 successes means 30 fails. So 6 out of 30, which does reduce to 1/5, or 1 to 5. Okay, here are all my answers for number 9. So we just have a couple more. Number 10 says, how many ways can a collection of 13 Pandora beads be arranged around a bracelet that has a clasp? Has a clasp means you can unclasp it and it becomes linear. So this is linear. So it's just 13 factorial. Now, because of reflection, you could divide that by 2, but I will count just 13 factorial. I'm not going to do reflection on the quiz. So 13 factorial is fine. And 13 factorial is a massive number, so here it is. Next one, how many ways can 6 people be arranged at a circular table? All right, it doesn't specify that there's a beginning, so this is definitely circular. And so we subtract 1. It's n minus 1 factorial for circular, so it's just 5 factorial instead of 6, which is 120. Ooh. Okay, how many ways can 8 homes be arranged in a cul-de-sac? All right, you could argue this one. Is it circular or is it linear? I'm going with linear though, because in a cul-de-sac, as many of you might live, I don't know, but you kind of have to like enter into it and then houses are around. This is the worst diagram ever. Okay, but there's kind of like a reference point. There's a beginning. So I'm going to go with that this is linear. And therefore, it's 8 factorial. However, if you went with 7 factorial, I think I'd be lenient on this one. So it's 40320. If you did 7 factorial, it would be 5040. But we're going to go with linear. All right, guys, one more slide. I know this is a lot, but I hope it helps. Whew, okay. So if I know that the probability of not winning something is 5 to 7, then I have to find the odds. Okay, so this is kind of weird, but this is the way I'm thinking about it. 5 to 7 means technically 5 is the success, but the success is not winning. So 5 is actually the losing. 7 is the total, which is win plus lose. So how many ways are there to win? Well, there's 5 losing, which means there's 2 winning. So what are the odds of winning? Odds of winning is going to be wins over loses because it's success over fails. So this is going to be the wins are 2, losses are 5. Answer is 2/5. Okay. Wow, last one. Now we're selecting cards, but this time it's probability. So this time we do have to make a fraction, and we do have to divide. The first one is the probability that I choose a face card. It's one card. So the total, or what should go on the bottom, is that I'm selecting from an entire deck. So it's 52, choose one in the bottom, because that's just the possibility of choosing any card. But for face card, there's 12 of them. So it's 12, choose one, divided by 52, choose one. And 12, choose one is 12. 52, choose one is 52. And that reduces to 3 over 13. Now, on the key, it goes right to this. The only reason it goes right to this step is because it's only choose one. But on the quiz, it might be more. You might be choosing more than one. So I want to show you all of the work. Okay? So for probability that I choose one black ace, again, let's zoom in. So again, I'm choosing from 52, so that goes on the bottom. And I'm choosing a black ace, so let's talk about this. I'm not just choosing an ace, which would be choosing from 4, but specifically a black one. So there's only two black aces in the whole deck, so it's 2, choose one. So this is 2 out of 52. Okay, because 2, choose one in your calculator is 2. 52, choose one is 52. And that reduces to 1 out of 26. Okay, whoops. Okay, weird situation. All right, probability that it's not a 10, which means it could be any other. Okay, really? Could be any other. So instead of counting up all the others, let's think about the fact that there's only 4 10s in the deck, which means that there's 48 other cards. So 48, choose one, out of 52, choose one, which is 48 out of 52. And that reduces to 12 out of 13. Okie dokie. The probability that it's not a black face card. Okay, so not a black face card. Well, how many black face cards are in the deck? King, queen, ace. Wait, no. King, queen, jack. Well, there's 3 face cards, and there's 2 black ones of each, so that would be 6 black face cards. So for it to not be a black face card, 52 minus 6 is 46. So we're from 46, we're choosing 1, dividing by the total, which is 52, choose 1. And again, 46, choose 1 is just 46. 52, choose 1 is just 52. And that reduces to 23 out of 26. Okay, just a couple more. So the probability that I choose a red card that's greater than 10 and ace is low. Remember, this is not a subtraction problem. They're just letting us know that ace is low. Okay. So a red card greater than 10. Well, the cards that are greater than 10 are jack, king, or queen, king. And there are 2 red cards for each of those. So there are 6. So it's 6. Choose 1 over 52, choose 1, which is 6 out of 52. So that's 3 out of 26. All right, couple more to go. Okay, couple more. So probability of a red 5, a black jack, or a king. So how many red 5s are in the deck? Well, there's 2 red 5s. So this would be 2, choose 1. Or a blackjack. There's 2 blackjacks in the deck, so 2, choose 1. Or a king. Well, there's 4 kings. It doesn't specify a color. So that's 4, choose 1. That all goes on top. And the reason I'm adding is because it is OR problem. So it's 2 plus 2 plus 4, which is 8. Lovely. So this leaves me with an 8 out of 52, choose 1, which is 8 out of 52, which is 2 out of 13. Last but not least, odds of selecting a 7. Okay, so the odds of selecting a 7, let's find the probability first and do the odds from there. So the probability of choosing a 7, there are 4 7s in the deck, and we are choosing from 52, so it's 4 over 52. Now let's do the odds from here. Obviously, the 4 would be the success, and this is success plus fails. So 52 minus 4 is 48, which means the odds are 4 to 48. That reduces to 1 over 12. And that's it. Oh, man. Okay, so sorry about this weird part. That's it for these problems, and actually the whole worksheet. So I hope that made sense. This was long, but hopefully that had helped. Have a good night. Bye.